All right, so we've got, how many more we got? 6? Is this the last one? What's that one say? What's the name of that next one? Oh, no, I say we're not doing that. Remember, on the lesson plans, right, I only went to 4 or 5, then I said we're going to review for a test on Friday. Yeah, so that means we're not doing 4-6. 4-6 wasn't on there. No. We're beginning a review on Friday. We do have a quiz. That's all right. It's all on RenWeb. You can check. All right, let's talk about this. Let's talk about this first thing right here, an inverse matrix and how we're going to use it, because we're going to use an inverse matrix to be able to solve a system of equations. When I say solve for a system of equations, what am I talking about? Yeah, if you had it, or it could be just an x and a y, right? And we used to call them simultaneous equations. Doesn't seem like books say that anymore, but that's what we used to call them. So let me talk about this briefly before we do the inverse matrix thing. If I had something like this, 3x plus 2 equals, 8. All right, and I ask you to solve for x. Basic, right, elementary algebra type of equation. So you have to get rid of stuff. How do I know what to do to get rid of something? Like the plus 2. How do I know to get rid of that plus 2 or what to do to get rid of that plus 2? I subtract a 2, correct? Because I'm doing the what? The opposite, or the what? Inverse operation, okay? What's the inverse operation of adding something? Subtracting. So we do it to both sides, correct? Cancels. 3x equals 6. Now we have to get rid of what? The 3. How do we get rid of the 3? Divide. Why do we divide? Because it is the what? Inverse operation of multiplication. That's right, because that 3 is being multiplied. So the inverse of multiplying is dividing. Or, you don't normally do this, but you could do this if you wanted to. You could multiply it by the inverse. Okay, what's the inverse of 3, or the reciprocal of 3? It's 1/3. Couldn't you do that? Isn't that the same exact thing? What I just said right there is going to help us with this matrix stuff, okay? So if I multiply by the reciprocal, or the what? Inverse, it's the same thing as dividing, because we don't really divide with matrices, okay? But we can multiply by the inverse. Everybody with me on that? All right. And then multiply by 1/3, x equals 2, and you're good to go. All right? So we're going to do that, but we're going to do that with matrices. All right, so let's first of all figure out how to find the inverse of a matrix. The inverse of a matrix isn't just like flipping all the elements inside the matrix. It's a little more complicated. It's not crazy complicated, but it is a couple steps. I mean, it's surprisingly complicated. So what if I give you a matrix A? I'm going to show you a very general way to do it. Then we'll put some specific numbers in. We'll do it a couple times just so that you get used to it. And then we're going to learn how to use that to solve system of equations. All right, so I'll just make this A, B, C, D. All right. Now, when you do the inverse of something, I don't know if you remember this from Algebra 1 or not, even if you did this in Algebra 1. Do you remember, like, if I said 2 to the negative first power? You guys remember doing negative powers in Algebra 1? Yeah, it's something you should have done in Algebra 1. What is this? This means if it's a negative exponent, thank you for getting the word. If it's a negative exponent, what does that mean you do? It means you take this and you flip it to the bottom. You flip it to the bottom, and then you change that from a negative exponent to a positive exponent. So we got rid of it here, flipped it to the bottom, so what do you have left? It's a 1/2, okay? It's a long way about saying that when you take something to the negative first power, you're just taking the inverse of it. Everybody with me on that? So if I take something to the negative first power, that means I'm taking the inverse of that thing. All right? So watch this. If this is matrix A, how do you think I'm going to write, what's the notation for the inverse of matrix A? a to the negative first. That's right. Okay? What does that mean right there? That means inverse. Okay? Anything to the negative first means it's an inverse. All right? Now, it is a matrix. It's not just any number, okay? It's a matrix. So here's how we do. It's two things that you have to do. All right? First thing you do is you put 1 over. That's a good start, right? Because when we think of inverse, we think 1 over something. Like 1 over 2 is the inverse of 2, correct? So it's going to be 1 over something. But what it is 1 over the determinant of that matrix. All right? Remember how we did determinant? You put the 2 bars. So I've got A, B, C, D. All right? So that's how you do that. And then times, put a little dot. You don't really have to put a dot. Now, watch what I'm going to do. I'm going to do something else. I put 1 over the determinant of that matrix, but I'm going to have to do a little more stuff to do the inverse. Now, watch very carefully. I'm going to take that A and that D. Actually, let's do it like this. Take that A and that D, and I'm going to switch places with the A and the D. Everybody see that? So what's going to go here then? D, and then down the bottom right is the A. Now, these two right here, I'm going to keep them where they are, but I'm going to change the signs of them. So I'm doing a lot of inverse stuff, right? That's like 3 inverse things. First of all, it's 1 over something. That's one inverse thing. I switch the order of these. That's another inverse thing. And then I change the signs of these two right here. Keep them in the same spot, but you change the sign. Keep this in the same spot, but we change the sign. And that is how you do an inverse of a matrix. Yeah, I told you, it's a little bit complicated, but once you get used to it, it's really not that bad.
So why don't we do 1 over the determinant?
It's just how it works. Okay? Do you remember like 2 times its inverse? What's the inverse of 2? It's 1/2. 2 times 1/2 is what? 1. So if I took this, and I think they do this in the book, but I just thought it was a little too time consuming, so I left it out. But if you look in the book, what number, like this AB, watch, A, B, C, D. What do I have to multiply by in order for the product to be a 1 or a what? 1001. Remember, that's my, what do we call that? Not a unit. Identity matrix, right? Remember, identity matrix is kind of like a 1, right? So, what do I multiply this by in order to get this? This right here. Okay?
Oh, that makes sense now. Okay.
All right? I'm not really showing you how you got to this. I'm just showing you what it is. I don't even think I could do that, figure out how they got this. But this is just how you do it. Okay? So see the stuff that I just circled right there? That's what you want to know. All right. So again, how do you find the inverses? And we'll do a couple examples here. All right. So 1, 2. Yeah, we'll do 3 different times we're gonna do the inverse. All right. So you'll get a chance to really understand how to do it. But again, what do you do? How do you find the inverse? It's 1 over the determinant of that matrix times, and then you draw another matrix. Then you do that. You flip stuff around, okay? You change the order of the top left one and the bottom right one, and then you keep the top right and bottom left the same, except you just change the signs of them. All right, Victoria, you getting all this? Not a good time to sleep, because there's a lot of stuff that we're covering on this. Somebody might want to help her out. All right, so let's do one. All right, let's do, and I think example 1 in the book, I don't have the book in front of me, because I did skip example 1, but I think it's showing that one number times that inverse is equal to the identity matrix. Okay, so if you want to look on there and see that it actually does work, feel free. It's on. I mean, I'm not saying it's not important. That's not why I skipped it. Just for time's sake is why I skipped it. All right, so let's take a look at example 2. It says find the inverse. Find the inverse. All right, they give you part A and part B. Part A, they tell you, matrix A again. It doesn't always have to be A, it just happens to be. So this is going to be 1, 5, -2, -4. Okay, so that's my A matrix. And so what am I trying to find? I'm trying to find the inverse, correct? All right, so let's go through it. It's our first time. What's the first thing we do? 1 over what? The determinant of this. All right, so I'm going to show all the steps. Like if you wanted to, you could like find the determinant over here off to the side, get a number, and then just chuck it in here. But I'm going to do it all within the steps. So that's 1, 5, -2, -4. We'll find the determinant in a second of that. Times. Now we do a little switcheroo stuff. All right, so what are we switching? The 1 and the -4. We switch places. So this is going to be a -4 up here, and this is going to be a 1 down here. You with me? All right. Now, what do you do with the other switcheroo? What do you do with these two? Just change signs of them. So that's going to be a -5, and this is going to be a +2. Got it? So that's how we started off. And really, the rest of it, you know already how to do. All right? We finished the new stuff. That was it. All right? You just have to do the work now. All right? And let's do that. So this is going to be 1 over. Remember how to find the determinant of a 2 by 2? Remember, cross multiply kind of thing. So 1 times -4 is -4. And then we put minus, right? -2 times 5 is -10. So it's minus -10. Yeah? I'll tell you what, instead of rewriting everything, let's just put what the determinant is. So what's that going to be? It's 1 over, what's that? That's a plus, and that's a 6. Right? And then you just put this, -4, -5, 2, 1. Now, in this particular case, they let you keep it just like that. Okay, they circle, well, they don't circle it, but they use that as the answer right there. Or you could multiply everything by that 1/6. So it's going to be what? -4 over 6. Reduce, what's -4 over 6? Reduce it. -2/3, correct? What's this? -5 over 6. Well, you can't reduce that, so you keep it -5 over 6. What's this one? 2 over 6, which is 1/3. And then this would be 1 over 6. So this is how you would get it just to be one matrix. Okay? But again, they allowed you to keep that 1/6 out in front. You'd have to look in the back of the book. I'm not sure if they want you to do that all the time. I'd be fine with either one of these, though. Okay? So that would be fine. That would be fine. I think we've done that before a little bit. Man, maybe it was the other class. I know it's been several weeks. We did that in we did this in my pre-calc class, but it was at least a month or two ago that we did this. That's not too bad, is it? Just got to remember the steps to follow, right? But it's really not that hard once you know what steps to follow. And really none of this matrix stuff is difficult. It's just you got to know what to do with it. I mean, there's a lot of little different steps. That's what makes it difficult. You don't really have to think too much. A lot of it's just basic calculations, but you got to know what you're calculating. You got to know, there's just a bunch of stuff to know about this. Because it's 1 over the determinant. The determinant was 1 over, and that's a 6, right? So that's 1/6. That's why I put the 1/6 in front of it. Everybody good? All right, let's do another one. Let's do part B. All right, and they call it matrix B for part B. -3, 2, 6, -4. And you are finding the inverse okay, matrix of this thing right here. So where do we start? It's an inverse, so we always go what? 1 over. 1 over what? The determinant. Again, if you wanted to do the determinant off to the side, feel free. All right, let's do that. So this is what? To do the determinant, that's 12 minus 12. What's 12 minus 12? 0, but look where the 0 is. And this is going to be multiplied by something. Do I even care what that is? No, why not? Because you can't multiply this by this because this is undefined, isn't it? All right. So that does not exist. So is there an inverse to this matrix? There is no inverse to it. And they say that b to the negative first, or the inverse matrix of, I guess you would just say the inverse of matrix B, okay, is undefined. All right, so that's how they write the answer. So that was super easy then, wasn't it? So you just got to be aware of stuff like that, okay? That's why they stuck it in there, because you never know. So there's nothing that if I multiply that, I'm going to get that identity matrix, that 1, 0, 0, 1. All right, there's nothing multiplied by that that will give me that. All right, so that's why it's undefined. We good? All right, remember the first thing I did about that 3x plus 2 equals whatever I said it was, 8, and then we did all that. Now what we're going to do is we're going to take this inverse matrix and we are going to actually use it to solve for x. So that's what this says. Solve for x. Now this is a capital X. So the capital X represents a what? A matrix, right? So this is example 3 in the book. So here it is. So it's 6, 8, 2, 3. And that matrix is being multiplied by x, and that equals negative 2, 0. And what are we trying to do? Solve for x. That's it. Solve for x. That thing right there. We want to get that by itself. Well, what's this doing to that x? What's that matrix doing to that x? It's multiplying. How do we get rid of something that's being multiplied? Well, we would divide, right? But this is matrix, right? Can you divide by a matrix? No, but you can take the what? The inverse of the matrix. So what happens if I take the inverse of this matrix right here? What do they do? What happens if I take an inverse, if I multiply the inverse times this matrix? That's what I should have said. If I take an inverse of this matrix and I multiply them together, what do I get? I get an identity matrix, which is basically just a what? A 1. So really, what did I just do by multiplying this by the inverse matrix? Look, if I had 3x equals 12, right? What do? Divide by 3, or let's do this. Multiply by a third. What happens? They cancel out. So what does multiplying this by its inverse do to it? Cancels it out. Everybody see that? But I can't just multiply this side by 1/3 and it cancels out x equals 12 and everybody's happy. Can't do that. What do I have to do to the other side? I have to multiply the other side by the inverse of that number. So watch what's going to happen here. I don't have to show. See, in algebra, I always put like divided by 3 or multiplied by a third or whatever, and we canceled them out. I don't have to do that work over here. I know for a fact that what's just going to happen, this is going to cancel out. But I have to do the inverse to the other side as well. All right? So here's what I'm going to do. I know this cancels out on the left side, so I get x by itself. But I also have to multiply the right side by the inverse of this matrix. So what's the inverse of this matrix? Well, it's 1 over the determinant of the matrix right, times the switcheroo, right? I don't know any better way to say it. So let's switch these. 3, 6, and then what's that? -8, -2. Yes? And what is that? And then I multiplied this by this, and it canceled out. So I multiply this side by this. So I got to keep that over here. That's a super important step that I just did right there. Simone, have you tried to wake her up? See what I did? So look, I took the inverse of this matrix on the left side. They canceled out, went away. And then all I did here, because you may not really see what I did there, I took this, I scooched it over, right? And then I took the inverse of the matrix in front of it. Okay, so I just pushed this over. I took the inverse of the matrix, I put it in front of that. And now I just work this thing out. Yes? Yeah, it's not that bad. All right, so let's do it. What I would do is a determinant first. So it's this. 6 times 3 is 18 minus 16. 18 minus 16 is 2. So what's that going to be? It's going to be a half, isn't it? Yes? All right, now let's multiply these two matrices together. Remember that? Go across like this, down like this. All right, so let's do that. So 3 times -2, -6, -8 times 0 plus 0. Drop down to the second row. -2 times -2 is +4. And then 6 and 0 is 0. Remember that, right? Just multiplying matrices, a 2 by 2 times a 2 by 1. We'll wait till the very end with that 1/2. All right? We will simplify it. So what do you get over here? Just -6 and 4. And now you multiply this thing on the outside times that. So what do we get? -3 and then a 2. And that is that. Okay, that's your answer. Yeah. I didn't even look how the book did it. This is how I do it, and I think it's just pretty straightforward. They got the same answer though, right? Yeah. Okay. Did they write it x equals -3 and x equals 2, or?
No,
they just, yeah, okay. Yeah. All right, one more example. Everybody still awake? Feel some people are nodding off. All right, here we go. Here's why we wanted to learn that, because of this example right here. This is where, at the very beginning of the lesson, it said solve systems of equations. Remember that it said that? Is that what it said, system? It just says solving systems, right? So here we go. We're actually, all that stuff that we learned up to this point, we're putting it to use, okay? So it's very, very similar to what we just did, but they start off with this. Now, I left a little bit out too. They started off as a word problem. Read it off to me, Mia. What's it? Example 4, what do they say? Like, okay, stop right there. So I didn't write this down. Just again, I was just thinking time, but it says a sum and twice a number. Or read it again, slower.
The sum of twice a number and a second number.
And a second number, okay. So this is the sum of twice a number and a second number. Everybody see that? So they're taking it from words and they're putting it into like an algebra equation. And then what's it say? Equals something?
8.
Equals 8. All right. And then they say what?
Well, 3 times the first number.
Okay, stop right there. 3 times the first number, what would we write? 3x. Keep going.
Plus twice the second number.
Okay, plus twice the second number. 2y equals what? 13. All right. So they took it from a word problem and we made it into this. Everybody okay with that? I just didn't want to write all that stuff down. It'd be a hassle. But that's what they wanted you to do here. So now what they want you to do is they want you to take this and they want you to use matrices in order to solve for x and y. Now, we could have used that Cramer's rule. Remember Cramer's rule not too long ago? I'd have to refresh my own mind a little bit. It's been a while since we've done that. I guess you could use that, but here's another way to do it, all right? This is the way that they taught in my pre-calc class. They didn't talk about Cramer's rule in that class, but anyway, this is what we're going to do. So what we're going to do is we're going to change this into matrices. I think we even had a quiz question, didn't we? Where you just had to change it to a matrix. You didn't have to solve for it or anything, but you just had to change it to a matrix form or something like that. All right, so what's that going to look like then? It's going to be a 2 and a 1, good, and then a 3 and a 2. Now, you could put a big old capital X there, but they don't. What do you think you're going to put? A little X and a Y. But you're going to see, excuse me, you're going to see this kind of works out the same as what we just did, all right? And that equals what? 8 and 13, yep. So now we are going to do what we just finished doing, and we're actually going to find out what x is equal to and what y is equal to. And it's kind of what we just did. You just didn't realize that's what we were doing, all right? Because if you look at it, watch this. I was really tempted before we did this problem. I was really tempted to do this. How could you write that as a system of equations? What would this be? This would be what? 6x plus 8y, and then this would be what? 2x plus 3y, and what would this equal? -2, and this would be 0. So really, that's what this was. All right? Everybody see that? So now we actually are seeing it like that. And now we solve for x and y. So let's do it. What do we have to do here? We got to get rid of this, don't we? We want to move it to the other side. So how do we do that? We take the inverse of it. So let's take the inverse on both sides. You know this is going to cancel out. I don't have to show that work. I don't have to show the inverse times this equals 1, 0, 0, 1. I don't have to do that. I know it's going to cancel out. All right, so I've got x, y equals. Now, what do? How did I get rid of it here? How did I cancel it out? I took the inverse of it. So I got to take the inverse of the other side. See, I'm taking that 8, 13, I'm just pushing it off to the side. I'll write that in a second. So how do I take the inverse of this matrix right there? Well, I put 1 over the determinant, so it's 2, 1, 3, 2, times. Now we switch the stuff up right here. Remember that? So we switched the 2 and the 2, which in this case didn't really make any difference, did it? All right, but what do we do with these two? Change signs. That's a -1 and that's a -3. Everybody with me? All right. So there's the inverse times what? 8 and 13. And now we just do the math. That's pretty easy setup, isn't it? You might like this better than doing substitution or elimination. I don't know. Okay, maybe not. It's all right. What's this? Let's do this in our head. 2 times 2 is 4 minus 3, right? This is 4 minus 3, which is 1. 1 over 1 is 1. So that made it super easy, right? They couldn't have given you an easier one to do here. So really, what do we end up doing? Just multiplying those together, all right? So let's do that. 2 times 8 is 16 plus -1 times 13, which is -13. Yes? And then do the second row. -3 times 8 is -24. And then 2 times 13 is plus 26. That gives you 3 on the top, 2 on the bottom. We're not going to leave it like this, though, because it says solve, find the numbers. Find what x is, find what y is. So what would x equal then? 3, and then y would be 2. And there's your answer. So really, I mean, if you did substitution elimination, I bet you'd be writing a whole lot more, wouldn't you, than what you did here? At first it is, because this is the first time you've seen it, obviously. Okay, so I would agree with you. But after you do them a while, you might revert to this. Like if you could do it any way that you wanted to do it, this might be the way that you choose to do it. Yeah. You should. That's a good point. You probably should write it as an ordered pair. That's true. Either way, I'd accept either way. But you are right. That's probably the preferred way to write the answer. We good? All right. Now, they have a whole section after that. They say use calculator. I'm not going to make you have to have it on a graphing calculator. There's no way you can do it on a scientific calculator. I'm not requiring you guys to have a scientific calculator. I know some of you might, but I'm not requiring you to have a scientific calculator. So I'm just going to skip those. They're basically X, Y, and Z's, right? So you could do this. I think in pre-calc, I think we did an X, Y, and Z using this method because you know how to find the determinant, right, of a 3 by 3. And you should know how to multiply, right, if you had 3 of them here. It's pretty involved, but you could do it if you wanted to. You don't have to have a calculator. I will not give you an X, Y, and Z to do it this way, okay? We did it with Kramer's rule, and it wasn't all that bad. All right, so if you really, really had to do it by hand and you didn't want to do substitution or elimination, you could always use Kramer's rule. We've done that already, and we didn't need a calculator. But anyway, the section on there, I don't assign any of the ones where it says use a calculator. All right, but you might see it, right? You might flip through the book. You're like, Mr. Hammer, you forgot this section. I didn't forget it. I purposely left it out because we got a million things to do the rest of this year. So I just... you got to pick and choose what you want to concentrate on, and that's what I decided to leave out. All right. Let's see what we got. I may... Did you guys get assigned this on Friday? But you really didn't know the lesson, though, did you? So, okay. So I may not do the evens, so don't get all energetic on me. And I mean, if you want to, you can. But I have a feeling, well, I don't know. Now, you know what? The way the calendar's working out for the quiz and the test, maybe we will. I think it'd probably be good practice to do them both. So today, we're just going to do 4-5A. All right, so we'll do 4-5A, and that's just the odds. So it's page 171, pages 171, 172. And we're going to do 1 to 21, just the odds. Tomorrow in class, we'll go over these, and I'll give you the evens as well. All right, just give you some extra practice on it. Right here, at least you'll know what the answers are for every single problem, okay? But again, don't just look in the back and write the answer down. You obviously see that there's quite a bit of work to show. There's no way I'm just going to accept you putting down an answer, all right, for something like that. All right? And you got that 4-4 as well, don't you? Tell you the truth, I'm just tired of talking today. My throat's doing pretty well, but I got another whole class I got to talk. Let's just turn it in, the 4-4. So you got A, B, and C, I believe, right? Yeah, why don't we just turn them in, and then you can start working on this stuff right now. You got 10 minutes, about 12 minutes actually, that you can start working on this right here. All right, so I'll collect 4-4, A, B, and C. It'd be nice if we split them. So let's do A first, then B, then C. All right. So, Matu, since you were already standing up, why don't you collect them for me? Okay. But make sure they're separated. I want them A, B, and C. So, Matu, come around and get A, and then come around and get B, then get C.